The International Council on Clean Transportation Projects states that by 2050, although around 90% of new truck sales will be electric, more than 80% of trucks still in operation will be using the internal combustion engine because of the longer working lifespans. Delivery vans are expected to transition to electric power more rapidly. Nevertheless, by 2050, an estimated 360 million delivery vans are still projected to remain in operation globally, with approximately 20 to 40% still using fossil fuels. Based on these projections, combustion power trucks and vans could continue to generate around 1.6 gigatons of carbon dioxide emissions annually by 2050. If 20% of the global commercial fleet adopted smarter routes for delivery route planning, tests suggest our optimization engine will reduce vehicle mileage by an average of 10%, and fleet-related emissions from combustion-powered vehicles could potentially be reduced by approximately 32 to 38 million tons of carbon dioxide per year. The International Energy Agency also projects that by 2050, 5 to 32% of global electricity generation may still come from fossil fuels. And a global consumption of 1,360 to 1,820 terawatt hours of electricity generation per year. As commercial vehicle fleets continue to electrify, reducing unnecessary mileage will not only lower electricity demand, but also reduce the emissions associated with electricity generation, where fossil fuels remain part of the energy mix. Assuming the same level of smarter route adoption and mileage reduction, global fleet electricity demand could decrease to an estimated 1,224 to 1,638 terawatts of power per year, potentially avoiding a further 23 million metric tons of carbon dioxide annually, depending on the carbon intensity of electricity generation at that time. Taken together, widespread adoption of smarter routes across both combustion engine and electric commercial fleets could contribute to an annual carbon dioxide reduction of approximately 55 to 61 megatons of carbon dioxide by 2050 per year. Assuming a gradual global adoption trajectory between 2035 and 2050, cumulative emission reductions could reach 413 to 960 megatons of carbon dioxide, highlighting the significant role that intelligent route optimization can play alongside vehicle electrification in reducing emissions in the transport sector.